We are building the Minesweeper project from the YByte Python curriculum available at www.ybyte.in. Uh, Previously, we saw how we have a function to tell us the neighbors of a given square. Now, having done this, we are back to the field list. In fact, we are going to update the neighborhood info on the fields list. The idea is that on all the squares that do not have a mine, we will update how many mines are in the neighborhood. Now, again, there are two possible approaches for this. The first approach would be to go to every square that is not a mine and then see around it, see how many mines are in the neighborhood. So neighborhood, of course, we know from the function that we created, but then we can go and see, okay, if all those are mine, then I know how many, what's the number that I should put. The second approach, which is more efficient, which is the approach we will take, is that instead of going to every square that is not a mine, in fact, we will go to every square that is a mine. And for that square, we will update every square in its neighborhood. See the difference between the two? In this case, I'm going to every square that is not a mine and updating that same square. Here, I'm saying, okay, let's go to a square that is a mine and update every square in its neighborhood. Very interesting, the difference. This is more efficient because obviously there are lesser number of mines. And we know that around every mine, so right now, if you look at the field list, every mine is, let's say that square is 9, but around that is all zeros. But then if you find that, look, around a mine, if the square that we're talking of itself does not contain a mine, then add 1 to the neighbor. And in fact, this will work. It requires a bit of thinking why it works. We'll talk about it, but let's see this approach. So what we are going to do is, remember we are going to run this on every mine. So I had a for loop in earlier to, let's say, make the field 9 for the mine locations. I will just extend that for loop saying that, look, now you should find the neighbors, and on every neighbor, if the neighbor itself is not a mine, which means the field at this location, for example, is not a mine, well, then increment that by 1. Let's first put this in code, see this working, and then we will talk a little bit more about this code. So like I said, I come back to my code. I'm going to do this as part of the for loop, which was already there, where I was updating the field. So now that I have, let's say, this for loop in. So notice the indentation. I just put a small comment. Let's say neighbor update. Now, first thing first, I find out the neighbors of this given mine. So I just go and use my function find neighbors of, let's say, log xy say 0 and log xy say 1. Now this basically is saying that, look, I know the mine location, find out all the neighbors of that location. Now I'm going to run a for loop on all the neighbors. So I just go and say for, let's say, neighbors in neigh, say neighbors in, let's say, nn. I ask myself a question, is this neighbor a mine or not? So if, let's say, field, say, I have to be a little bit careful because this is a list of lists, and neighbors itself is going to be a tuple. So I just go and say neighbors, say 0, and neigh neighbors, say 1. If this is not equal to 9, which means this is not a mine, I will in fact set the field. Okay, so I need to have a colon over here, and I will set this to plus equals to 1. Basically, I'll increment this by 1. Now, first, like I said, let's see this working because seeing is believing, and then we'll try to explain why this is working and think a little bit more about this code. So I run my code and I get my, let's say, the board as expected. I can look at the locations. Those are these numbers. Now let's look at the list called field. So I'm just going to say display field. You notice that now around every mine, the neighborhood has been updated. Let's look at a specific mine. For example, this location over here, which is basically coming from the 6 here. So 0, 1, 2, 3, 4, 5, 6. We notice that all the adjacent cells, which are basically the neighbors, they have all become 1. And why did this happen? Because remember, the code basically went mine to mine. So the code would have gone to, let's say, this mine and incremented every value around it. So that has become 1. Let's look at, let's say, for instance, this over here. Now this cell has, this square has a mine, and I see 2 on these, let's say this particular square. Now why has this happened? Well, because remember, this particular square here is a neighbor of this mine. It's also a neighbor of this mine. So when I basically went and incremented for the mine, this contributed 1 and this mine contributed 1. That's why this has become 2, and clearly this is correct. We can look at, let's say, this cell here. It's telling me there are 3 mines around you, and that sounds logical because look, this, notice, say you look, this mine has contributed, this mine has contributed, and also this mine has contributed. So it sounds very logical. It has basically done the job that we are looking for. Now every cell has a neighborhood information. When the neighbor is 0, it means that there is no, neighboring, let's say, there's no mine in the neighboring cells. So the job has actually happened, but let's try to understand why did this actually work. So the idea is in fact quite interesting. Like I said, basically let's imagine a scenario where we have 2 mines, let's say, adjacent to each other. Now first, let's say I go to this mine, just for illustration's sake. Now when I go to this mine, I am going to increase all of these by 1, assuming it was all 0 to start with. Of course, this is a mine here, so I will not respond to this cell. So basically it will become, let's say there's a mine here, there's a mine here. All these squares would have got a 1. Next, let's say I go to this mine. Now this mine looks at its neighbors. Wherever there is not a mine, it's going to increment that again. So basically around it, so these squares will become 1. These 2 squares, which is, let's say in this case 4, 2 and say 3, 3, these 2 will become 2, and so on. If you think about it, the entire minefield will in fact get updated. Clearly, this is a lot more efficient than having to go to every square and updating every square. So this is very nice sort of code in some sense, makes us think. And on that note, I want to raise a food for thought for you. We are running this loop mine by mine. This is actually quite interesting. Think about it. Basically, we are going to, let's say, mine number 1, mine number 2, mine number 3, mine number 4, and so on. And we are running this code around the mine. Now, the consequence of this is actually quite interesting. Notice when I'm running, let's say, for mine number 1, I have no idea that perhaps mine number 6 is going to end up in one of the neighbors. Now, seeing this in the reference of this diagram, what I'm trying to say is that it's possible that when I'm running the code for this mine, in fact, this mine has not yet been placed, which means that in fact, this square will become a 1. The question then is, does it matter? So you might wonder, should we not first place all the mines, which means make all the mine squares 9 in the feed list, and then do search of neighbors, which means that in coding terms, do a for loop here, do another for loop, a new one to find, let's say, to test for this condition. In fact, it doesn't matter. I would want you to think about it carefully. The reason is that, let's say I run my code for, say, this mine, and this mine has yet to be, let's say, identified or placed there. It doesn't really matter because, yes, I'll make this 1, but the moment this mine comes in, it's going to override this again to 9, and I will run my update on its neighbor. So in fact, it will work out. Happy to discuss this, but do think it over. Such subtle points are important to think about because that is when you're really thinking about your code, really understanding what is going on in there. I hope you found this interesting. At YByte, we always build activities and think about every part of code that we are putting in there because that is how we learn Python programming. Look at our website, www.ybyte.in. You'll find that there are many activities through which you can learn Python programming. Take care. Thank you so much. Bye-bye.